So hi guys, welcome back to my channel. So in today's video we are going to discuss about how elements are indexed in a numpy array and how we can select elements from a numpy array. So which is basically indexing and selection. So without further ado, let's take a look at few examples. So in this video we will be discussing about indexing and selection in 1D and 2D arrays. So first let's discuss about 1D arrays. So numpy as np. So first let's import numpy library into our program. So now indexing in a 1D array is similar to indexing a Python list. So let me first create a Python list. I'll compare both Python list and 1D arrays to show you how they are done. So let me create a list first and let me create an array of the same list. Sorry. So for indexing a Python list, to get this zeroth, we all know that indexing starts from 0. So to get this zeroth element, we need to specify the index, which is 0. So we get 0. Similarly, in a list, first let me print the list. So to get the zeroth element, we just need to specify the index. So yeah, you can see that indexing of a 1D array is similar to indexing a list. So let me show you few more examples. So to get the element from 0th position to the 3rd position, we need to specify this. So as you all know that it will include the 0th index, but it won't include the 4th index. So 0, 1, 2, 3. So the elements present at 0th till the 3rd index will only be printed. So similarly in a list, in a array, the 0th index is included, element in 0th index is included, but the element at 4th index is not included. So let me show you more examples of the array. So to get all the elements from the beginning to the, let's say, 4th position, we just need to specify this. So this empty value suggests that we include all the elements from the 4th index and before. Similarly backwards, to get element from the 2nd index and rest of all the elements, so we need to specify this. So it will include the element of the 2nd index and all the rest of the elements of the array. So let me tell you how a Python list differs from a array. So I have my array as arr. So if I specify 0 colon 3 as 1 and print my array, so you can see that all the elements from the 0th index to the 2nd index is set to 1. So similarly, if I try to do that to my list, you can see that I am getting an error which says that can only assign an iterable. So this is the main difference between a Python list and an array. So the arrays in Python have the ability to broadcast. So now let's move on to indexing and selection in a 2D array. So first let me create a 2D array. Okay, so now I've created a 2D array which is a 3×3 matrix. So if I print this array, you can see that I've created a 2D array with 3 rows and 3 columns. So now there are two methods of how we can index a 2D array. The first method is the double bracket format, and the second method is single bracket format with a comma. So the recommended method is the single bracket format with a comma, but I'll show you the both methods. So for first, let's see double bracket format. So in double bracket format, we just need to specify the row in the first bracket and the column in the second bracket. So if I give 0 and 0, then you see I get this value 5. So since this is present in the row index 0, and the column index 0, so it printed 5. So if I want to print 15, so it is present in the row index 0 and the column index 2. So to get that, I just need to do it as 0 and 2. So yeah, you can see it. Now similarly for the single bracket method with a comma, it's quite similar. So we just need to specify the row in the first argument and the column in the second argument. The difference is that the row and column are separated by a comma. You can also get just the row of the 2D array. So to do that, we just need to specify the row index. So if I want to get this 35, 40 and 45, which is present in the row index 2, I just need to specify 2 over here. So you can see that I got 35, 40 and 45. Okay, so now I'm going to show you how we can get the sub matrices from a matrix. So we have this array arr underscore 2d, which is a 3 by 3 matrix. So if I want to get 10, 15, 25, 30 from this matrix, I can do it by, so in the first parameter we'll be passing two arguments. So in the first argument we just need to specify the number of rows. So in the above matrix we want this row and this row, which are the row in the 0th index and the first index. So we can do it by just typing everything from the starting to the first row. So for the first row I need to specify 2, because 2 won't be included, but first index of the row will be included. And to get the first and second row, I need to specify it as I need the first row and everything after the first row. So if I do this, then you can see I got 10, 15, 25, 30. I know that it takes it will take some time for you to understand this, but it's really easy if you try more. So one work which I'd like to give you guys is that I want you guys to select 20, 25 and 30, 35, 40 from this matrix. So we can do that just by doing, we need to specify the rows. So I need the row in the first index and everything after the first row. So I need first and second row. So I'll specify 1 and colon, comma, and I need the 0th row and the first row. So I need the 0th row, so I won't mention it, and I need the first row, so I'll give 2. So if I print this, you can see that I got 20, 25, 35, 40. 20, 25, 35, 40. So it's really easy. So another basic example which I like to show you guys is that first let me create a 1D array from 0 to 11. So now so if I wanted all the elements in this from this array which are greater than 5, so what I'll do is I'll just do it as 5. So you can see I got all the elements from this array which are greater than 5. So how this works is I'll specify a bool array as 5. So if I print this bool array, so you can see that all the elements which are greater than 5 are mentioned true. So since 6 is present in the sixth index, so index at 0, 1, 2, 3, 4, 5, 6 is true. Index at 7 is true, 8 is true, 9 is true, 10 is true. So all the condition, all the elements which specify which uh, meets this condition will be set to true. So now if I pass this variable into our array, so what this will basically do is it will only print those elements of the index whose values are true. So yeah, this is how actually how this statement had worked. So now we'll be discussing about basic operations on NumPy array. So in this we'll be discussing mainly array with array operations, array with scalar operation, and few functions in NumPy arrays. So first let us discuss about array with array operations. So let me create an array using a range from 0 to 10. So I'll pass in 11 in the array. So now let us perform addition operation. So for that we just need to add two arrays. So the index and the similar indexes will be added together. So 0th index will be added with 0 index giving 0. First index will be added with the first index giving 2. Similarly this goes on. So now we can perform subtraction as well. So this should give us 0. Similarly with multiplication, and similar with division. So you can see that when I try to divide 0 with 0, it gives me a warning, but it doesn't send me an error. It prints the value as nan. Okay, so these were the few examples of array with array operations. Now let us see array with scalar operations. So I have an array. Now if I try to add 2, then you can see that every index of the array will be added by 2. So you can see 10 was added by 2 and it gave us the result as 12. Similarly for rest of the elements 2 will be added. Similarly subtraction can be performed, multiplication 4. Every element of every index will be multiplied by 4. Similarly with division, so you can see it. So now let us see few functions in NumPy array. So if I wanted to get the square root of every element of this array, then I can do that just by using sqrt and passing in the array. So you can see this will return the square root of every element of this array. So we know the square root of 4 is 2, so it returned 2. Square root of 9 is 3, so it returned 3. Square root of 10 is 3.16 and so on, so it returns us this. We can also find the exponent of the particular array. So it will give us the exponent of every element with itself. So guys, I've created a list consisting of elements 0, 30, 45, 60, 90, and I've converted that list into an array called arr_2. So now I can perform trigonometric operations on these arrays. So if I pass in that the np.sign